Welcome to the session. I hope you guys are having a good time. Okay, perfect. So in this session, we'll talk about a lot of interesting stuff. We'll do hands-on. I'll do the hands-on. You'll see. But the essential idea here is to see how we can use the API to do something which is sort of more idea to prototype, like sort of prototype to production. And that's what we're going to do. Myself, Lavi Nigam, I'm a developer advocate at Google Cloud. And let's see what we're going to talk today. So the first thing is we'll try to create a persona of a developer. Me being a developer, I would like to sort of do it in this way where I take a problem, I think of myself as doing exactly the same thing which every developer would be doing. And that's exactly what we'll do. We'll try to create a persona. We'll try to introduce some of the Gemini models. And then we'll see some of the requirements from a leadership perspective, from a developer perspective, and then we'll go through a bunch of notebooks, three essentially. And then the last part, which is my favorite, where we'll try to extend the idea into more sort of production-ready things. More on that later. So let's start with the developer challenge. And like I said, I'm going to take a persona. So imagine that I'm working in a financial firm and the boss comes to me and says, hey, we want to automate a bunch of stuff that, let's say, analysts are doing. And how can we do that? What are the things that we can help them achieve in that sense? Now, the problem statement that has been given is, let's say we want to sort of reduce the research time and cost for the financial analyst team. And to do that, what we need is we need to solve this problem from a multimodal perspective, because if you think about the work that analysts or researchers do, they essentially go through so many different kinds of sources. They go through reports, they go through PDFs, videos, audios, earning calls. There's so much modality sort of involved in this, and essentially that's what our problem statement is. At an idea stage, I would want to sort of prototype this and see whether I'm able to build something quickly, right? And of course, as with most sort of prototypes, you're not given too much time. And the flow that I come up with as a developer is that essentially I need to start with a source document, and this could be reports, company videos, earning calls, images, bunch of those things, right? And then what I should be able to do is I should be able to ask questions, irrespective of the modality. So things like what was the revenue, what's the analyst question asked to specific person, how is X product doing, and so on and so forth. And all of that should be able to give me back the answers. Now, of course, as a developer, the first thing is we all do research. We go back to the Google. We try to figure out what are the different models that we have. And in this case, for obvious reasons, I'm going to come back to the same problem statement, which is I need to sort of validate the multimodality of this problem statement. So I need to sort of understand how can I take all of these modalities, get to the answer quickly. The answer, of course, in this case is Gemini. Gemini has sort of these different layers where you can pass these data points. It's built sort of responsibly. It has sort of different choices in terms of models, which you all see yesterday. So that's pretty much what we are trying to do. But the most important feature here is multimodality, like I've been saying so many times, and you can count the number of times I'll say this in the overall presentation. But essentially, that's what we need. The core feature beyond anything is the contextual windows of 1 million and the multimodality that we need to solve this problem from a validation or the prototype stage. So before we jump onto the notebook where I show you how we can do that, let's quickly sort of summarize. And this is, again, something that we all face as a developer. We always have requirements from the leadership that, hey, we don't have budget, it should be quick, cheap, there should be a lot of process across the flow that you need to have, which we just saw in the previous slide. It should be simple enough, the scope should be reduced, and from a developer perspective, again, the cost should be less. I should not spend too much time building something. It should be very easy for me to sort of build those things. It should be very easy for me to validate the ideas that I have. And then, of course, the documentation, the cookbooks and examples, bunch of these things, right? So that's what we should keep in mind when we look into all the notebooks that we'll go through today. Okay, let's dive right into the notebooks. Let's get to the demo part. All right. So, like I said, I have three notebooks, and I'm going to sort of zoom this out so that you can get and maybe take a picture if you want to see the notebooks. I'm going to show this 3 times overall because we have 3 notebooks, but just in case if you want to sort of see all of these notebooks, it's hosted on my GitHub. I've also given the quick links for the cookbooks. Go ahead, sort of explore those things as well. Okay, so again, do remember we are trying to sort of validate whether I can help my boss create this prototype. So I'm going to use Google AI for developers and the Gemini API that we have. Let's see the sort of very basic steps, step by step. So I'm going to install a bunch of libraries, especially the Google Generative AI SDK, which is important. This is what we're going to use. Once I do the installation, and again, I have ran all of these steps in the morning, so these are all pre-cached, but the notebooks are available online. You can go back, run this, and you should be able to sort of run everything as it is. The next thing is I'm sort of downloading a set of data. Now, this data is very interesting, so if I go and show you, this is the initial set that has been given to me. So if you see these files are essentially a bunch of PDFs, MP3, videos and audios and things like that, right? So this has been given to me as my initial test that, hey, if you can ask questions to these files, then we're good. Like we're good to sort of prove that, we can do these things very easily. So I essentially download these files, and all of this gets downloaded into my collab, which is to say the runtime that I'm connected in the back. Then I essentially import the libraries. I do the authentication, which is again a very standard thing. You can get your keys in the Google AI Studio, configure it, load it so that you can access these models. Then I do 3 very simple things in terms of sort of loading the models. I first import all the specific classes that I need. I define my config, and this is how you can define your config. I'm taking the temperature 1 in this case. I can define the safety settings because again, a lot of times, especially let's say you're in a psychology kind of a domain or a healthcare, you might get into some troubles where things will be blocked by default, but you do have control to sort of change those settings. And that's what I'm doing. I'm saying, and there are sort of 4 different levels. You can refer to the documentation. And then something that I'm doing is I'm importing the model. So I'm now importing Gemini 1.5 Pro latest. Very important for us to keep this in mind, the namings of the model, because when we'll jump to the cloud side of things, the model names might change. And this was not originally part of the demo, but I just got really excited and I thought, why not add Flash as well? So I'm going to show you a couple of examples of Flash as well, just to sort of compare and how things sort of work. But as you can see, it's pretty same. Like there's nothing changed except the name. So we are importing these 2 models. The next thing is I've written some helper functions, which essentially does very simple things, which is you take a PDF. This is a blog. The blogs typically, and let me sort of quickly show you this. So if I open that blog, the good thing is this blog has combinations of images, so something like this, graphs and architectures. And we'll try to see how we can leverage this, because all of you know that LLMs are great at doing text extractions and doing things, but how about sort of reasoning with the images which are present, right? So we'll try to go there as well. We'll try to see how we can do that. But as a first step, I just want to make sure that I can do the text part perfectly. So I have written a simple function which goes through a PDF, extracts all the text, saves it in a simple return statement, and then I'm just sending it to the model. And I'm asking a simple question. So as you can see, I'm asking what are the key achievements for Google Cloud from the following blog, mention in bullet. And I'm using a rich markdown here. So this is not the actual output. This is the markdown display of the output. And you can see that it was able to sort of give me, and the funny thing is, it actually just took 14 seconds. And this is not the Flash model, this is the main Pro model. It's pretty good. Like you can actually go and see whether these details are correct or not. I have taken that pain and done that, and all the details are pretty much accurate. It's sort of quoting all of these things from the document. I can do the same thing because the code has been written in such a way, and it's so simple, you can just see there's nothing going behind. You can see that I'm just changing the model Flash now. So initially I was calling simple model, which was 1.5. Now I have model Flash, and you can see that it still gives me the output. But this time, the time is sort of almost the half of the Pro model. So that's what we were trying to sort of do, which is we want the models to be faster. So if you have use cases where things are not sort of very complex, you're not trying to do very complex reasoning, you can just sort of send it to this. and you'll get the answers pretty fast. And again, this has 1 million tokens, so there's no difference in terms of tokens. Okay, let's move forward. I have another file, which is a quarterly report for Google, and I have a bunch of questions. So it's not restricted to asking one question. I wanted to see whether I can ask multiple questions or not. So I use the same function as before, and I say, hey, can you take this PDF, extract all the text, and then sort of give me something. By the way, this PDF is almost like 40, 50 pages. So you can see this is where the long contextual window sort of comes in handy. And I'm sort of trying to be very greedy because I'm saying, hey, I have all of these questions. Can you sort of answer all of them in one go? And most of these questions, if you notice, they are essentially very financial analyst questions. Like, that's the kind of question they would want to ask, right? And again, I do the same thing. And the moment I hit enter, again, it takes sort of 14 seconds, goes through a bunch of text, and then gives me the results in a very proper format. Not only that, one of the very interesting things which I observe quite frequently with 1.5 is that sometimes it gives you that, hey, you were asking something, but it's not sort of given directly. So it tells you that, hey, for me to answer that, I would need extra detail, or you would need to provide some extra sort of context. And that's what you see towards the end. It says, if you want me to give you the comprehensive understanding, can you please provide me all of these things as well? You can also quickly check all the different models, because it's not just the two models that you have, but there are many different models that you have there. So you can just sort of do a simple GenAI.list models, and there you go. You can see that you have different versions of Gemini, you have text embeddings, and so on and so forth. Okay, let's move forward. So there are two things that we have validated. Let's see if we can do something more complex, like an audio. So here I have earning calls. Again, these are sort of videos which you see on the YouTube, but they are sort of recorded calls, and we would want to ask questions to the audio directly. I sort of load this, and you have a very simple function which uploads your MP3 to the cloud, so that you can sort of directly send it to the model, which you can delete, by the way. So right after you get the answer, you can sort of delete that. And then again, I ask a very specific question. And these are the questions which I love, because I'm trying to be very sort of not direct. So I'm saying, what are the major comments by Sundar and Ruth? I'm not mentioning their full names, because I'm assuming that it should have intelligence enough to sort of pick these things. And I'm also sort of trying to be very confusing. I'm asking so many different questions, and I'm trying to sort of compound everything together. So I'm saying, what were the names of those analysts? Give answer in bullets, and what were the key questions that they asked? If you see the answer, this is processing the whole 1 hour audio. It took 49.1 seconds roughly, and then it came up with all of these things which I was asking. So this is what Sundar Pichai said on AI. This is what Ruth Parat said on AI. And again, these are the names of the analyst, the question that they asked. This is fabulous, because imagine, again, every time you see this, imagine that this is what that analyst would have to do by going through that video for 1 hour and then making note and then sort of summarizing the whole detail. But now they can just do that. So for me, this is good, because, like I said, I've validated another modality, which is the audio part. Let's try Flash, because we said it takes less time. So the next step I do is I actually try Flash. In this also, you can see that it took slightly lesser time. It's 29.6 seconds. And then it again sort of gave me pretty much most of the same information. And that's where you start seeing slight differences. Like, if you're looking for very comprehensive, detailed, reasoning-oriented, you would prefer, and you don't have latency sort of issues, you would prefer 1.5 Pro. If you're like, no, I want the quick answers, I don't care enough, this will be very important when we'll actually go to the production side. All right, so far so good. So, like I said, I was showing you that PDF where there was a lot of images, and I want to also sort of check whether that is a possibility or not. So what I do next is, and there are different ways of doing it. This is just one way that I thought would be interesting, which is I take each page of the PDF, use it as an image, and then I set all these 20 pages as images to Gemini and saying, now can you answer my questions? So it's a very different, tricky thing. You're not sort of asking the text, you're essentially asking the image. And each page is an image, because I'm saying, hey, if there are so many graphs and everything, why not sort of do that? And again, I've written a simple function. Go ahead, see those functions. They're very simple. They're not complicated. And then I ask, again, a very specific question. I say, what is the EMFU and BF16, blah, blah, blah. So many different weird things that I'm asking. The interesting part is I'm asking it to cite the table and page number and explain the significance of the result. So this is where I'm sort of doing two things. I'm asking it to cite so that I know that it's not hallucinating. And the second thing is I'm asking it to sort of reason through the whole thing and give me why this is sort of significant. Again, it took sort of 42 seconds, but it tells me exactly the things that I was looking for. That answer is not directly available in the given document, and it sort of clearly identifies that and says, hey, what you're looking for is not directly available. However, there is a way for you to get to that information, and that's what it sort of details back to me. And towards the end, you can see that it also tells me the significance of that. I do the same thing with Flash. It took just 2.9 seconds. This is impressive, right? And again, if you read through it, it says the similar things, which is, it's not directly available. You may want to sort of do or provide extra things, and here's the significance. And that's what I was mentioning, that every file that you upload, you can actually just delete it right after you ask the question. So it's not necessary that you have to sort of keep those files always in the cloud. All right, so the last thing is the video. This is one of those challenging things, and I have one video from the last year, which is AI and the Google search. Now this year, feel free to sort of load any other MP4 as well. There's a little helper function that you would have to write, which sort of extracts all the frames and then send those frames to the model so that it can sort of give you those reasoning. I'm doing exactly the same thing. I'm saying, hey, describe this video and how is Google using generative AI in search, give response in bullets. And you can see the simplicity of all of this. I'm not even trying to do any kind of system instructions, profiling, or act like this, act like that. I'm just trying to be very, very simple in sort of trying to ask these questions. And it's a deliberate thing, because when the analysts will use a system like this, they would not do all of these things. Like as a normal user, they would write the way they think, which is random combination of everything. So I do the same thing again, and you can see that again, it sort of goes through the whole 1 hour video. Sorry, this is not a 1 hour video. This is sort of 20 minutes video, and it took roughly 8 to 9 seconds. And again, it sort of gave me all the summarizations and so on and so forth. I do the same thing in the Flash, and it sort of took 5 seconds, slightly less. But again, it sort of came back with the results. The last thing is, I can also get to the embedding part, which is I can have a text and I can convert this into embeddings. Now, I'm going to assume that a lot of you know what embeddings are, but at a high level, just imagine that you're taking a bunch of text, converting into numbers, and these numbers are going to help you then later find out similar things together. That's all we need to know right now. There's a whole theory, maths behind it. I would say that you can go back and sort of explore that more. So I'm using the new model, Text Embedding 004, which is one of our powerful models that we recently launched. So now, so far, we are good. So going back to the presentation. So we did the first part of the validation. Let's go back to the presentation. And OK, so as a developer, I can say, all right, I'm happy. And I can make my boss happy, because I can say, hey, the files that you gave and the models that I have access to, I can pretty much sort of do most of the things that you asked me to. And it is able to sort of go through each and every modality that I threw at it, and I'm getting the answer. So I'm sort of pretty happy. The boss is pretty happy. And as with most things, you know how the leadership sort of becomes greedy, and they're like, hey, if you can do this, why not sort of scale this up? They're really happy because of the results that they're seeing. So now you get the new requirements, and slowly, like I said, we are moving into the lines of the production. So the new requirements looks like this, where the leadership says that, hey, this is good, but then if you want to do this inside the financial domain, we need to really do things sort of slightly different, because there's a lot of security, there's a lot of integrations, there's a bunch of things that you would have to do when you want to make things sort of more secure. So they gave you these requirements, which are, it should have some kind of an access control. Not every analyst will have access to every kind of file. You have some kind of access control that you should have access to. It should be able to scale. Right now, we are doing this on 10 documents. How about doing this on 100,000 documents? You need some kind of a platform, some kind of a service which can help you scale that. You also need a platform because, again, for most of you, when you build services, it's not just one simple prompt and getting the answer. There's a bunch of things and bunch of microservices that you need to write. So you need to be in a platform where you can do all of these things very, very easily. And then security, of course, that's one of the major things that you would always want to focus on. But from a developer perspective, again, as a developer, you'll be like, I don't care about any of those things. I want things to be easy. And that's where I don't want any of the work that I just did on Google AI, Gemini API to go waste. I want to use all of that, which means I should have a very easy migration. I should have a storage. I don't want to use Google Drive because my analyst would not save it there. I need to have a lot of operations, and this is where ML ops, LLM ops, and all of that comes into picture. I should have ecosystem where I can do all of those things. And of course, the tuning part, the tuning, the RLHF, distillations, bunch of other fancy things. Of course, we don't have time today to go through all of these things, but we'll try to sort of build our ideas around it. And later we'll see that how we make ourselves sort of more enterprise ready without sort of doing everything on day one. We'll sort of try to be ready for that. Okay, so let's jump into the demo. Do remember, like I said, the goal here is very simple. We just want to reuse the code that you just saw, and we just want to see how easy it is for us to do so that when we are in the cloud side of the things are sort of enterprise ready by default. Again, I'm going to give you the links. This is where the notebooks are. If you've not taken a photo, feel free to take the photos. This is where you see all the notebooks and the cookbooks if you want to sort of explore more. Okay, so I'm not going to go in detail of this notebook because it's exactly doing the same thing as the last notebook, but I'm just going to show you the things that change when you go between two platforms. For whatever reason, again, you don't have to, but if that's your choice, if that's what you're trying to do, you would want to remember the migration that is required. So of course, because you're moving between platforms, you would change the SDK. So now I'm sort of doing Google Cloud AI platform. The authentication changes. So previously, when we were doing the API key, this would not work similarly in the cloud. In the cloud, you need sort of your cloud account, you need project ID. There's a lot of security layers in those things for obvious reasons because you're trying to sort of make sure that everything remains in your tenant, nobody has access other than this. So that's a bunch of steps that you would have to do, and that's what I'm doing here. I do the authentication. It sort of gives me access to my tenant, where my data should be so that I can do all the things and nobody else can do that. I'm downloading the same data from Drive just to make a point that we can actually use the Drive things as well as the cloud storage as well. So I'm downloading the same thing. Importing would slightly change for obvious reason because you're doing that. This step remains same except the name. So if you now focus on the name part, you will see that in the other side you had at the latest. In this side, you would want to sort of remember that the name slightly changed because now in the cloud, you have still preview because the SLAs are slightly different when you do this between cloud and the outside. So here you will have a keyword preview and for the both models. And again, I have both the models here as well. So both the models are available in both the ecosystem. This code exactly remains the same. No change whatsoever. I run the same code, same helper function, just to show you that just by changing few things, you can sort of just switch between the platforms. All right, good enough. So now if you go through all this step, everything sort of remains the same. I'm running the same flow. Just want to point out one quick thing. So this is where you have an option. You can still do and read things from Google Drive. But because I have access to cloud storage, I can actually put things in cloud storage and read everything from there directly without the need for me to download anything in the central location or any server or anything. I can just point the model to say, hey, here's the file, which is where you see my GCS URI. And I say, hey, here's my file. Just go and sort of give me whatever I'm looking forward to. And that's one thing to keep in mind. And that's one of the things that will come in very handy in the next part, where we'll try to not download anything and do everything sort of in memory so that there's no footprint or anything of the files that we are playing with. So you saw both the options. So you have flexibility to either use open data if you wish to. If you're like, no, I want things to be secure, you can sort of put it in the GCS bucket and call it a day. Rest, everything remains same. All the same code, same prompts, nothing changes, same output and everything as is. Okay, back to presentation. Because like I said, we are moving towards production slowly. So now we know that we have a good migration that we have done. So we are in cloud. And next, we'll see why and what do we do in the cloud. So just to do a quick recap, the API when you move between these two different things, there are only three things that needs to be changed or updated, which is the library installation, dependencies, and authentication. If you just focus on that, rest everything, your helper functions, your prompts, your instructions, everything remains same. So you don't make that change. And again, I want to be very specific. I'm not saying do that shift or migration. You have option both the ways. Whatever you choose, as a developer, I like choices. I don't want to be forced into a direction. And that's where this slide comes in handy, that if I ever want to make that sort of move, I know where and what to do with this. So this is good, but let's talk about production, right? Because again, production means lot of things. Production can be so many different things to so many different people, so many different companies. I'm going to do something different in a sense that I'm going to create a flow, or let's say just the extension of what we are trying to do. So on the left is what we are doing right now, and bear with me, and we'll sort of slowly understand what's happening. On the left side in the prototype, I had to choose a file and ask a question, which means I need to know which file and what question to ask, right? Like I would need to know that. Can we automate that? Can we make some kind of an intelligence layer where I don't need to know what file the answers are available? I should just ask the question, because now again, think about it. Isn't that what analysts would want to do? They're like, I don't care where the information is. I need to know what these things are. You figure this out where the answer is available. And that's exactly what we are trying to solve in the production flow. You can build that production flow in either of the ecosystems. There's no only this will work here and not there. You'll see that in the code itself. But we are taking one well-lit path. We are saying, okay, now because we are in the cloud and we are trying to be enterprise ready, let's build that intelligence layer with the use of different models, embeddings, so that later I can just ask a question and it should, A, find those documents where the answer could be, and then give me the answer. So that's the kind of automations we are trying to do. Just a quick thing, because a lot of people do get confused as to why are we trying to be on the other side. And this is where I said, we are trying to be enterprise ready. We're not trying to develop everything on day one. We are trying to be ready for the future requirements. And what it means is essentially you need to have ecosystem components where a bunch of different things are available to you. So Vertex AI is one of those features in the cloud where you have different models, you have Collab Enterprise, workbenches, AI Studio, developer SDKs. You have a bunch of these. And again, the difference here essentially is that these are all managed services, right? These are not services where you would have to worry about a lot of things. So this is almost like a software as a service. All of this taken care, so you can augment your things, you can customize, you can train, you can use RLHF. Bunch of these things are already built in there. You just use, do, and call it a day. And then you can also sort of do a lot of orchestration, MLOps layer, and bunch of those things. And it doesn't sort of only stop there, but this is just one part of the cloud, which is the focus GenAI part. But the big aspect is the cloud has so many things, and I'm not going to bore you because I'm not the sales guy here, but there are a lot of things. There are sort of compute, storage, networking, all of these things, right? So let's get back to the demo side, and this is one where you'll have a lot of fun. Okay, so before I do that, I just want to quickly show you that just the Collab that we are using, there's also an enterprise version of that, where if for whatever reason, again, we are trying to be secure, right? We are saying, hey, I don't want to use any of these things on the outside of the world. You do have Collab inside the cloud ecosystem as well. And this is how it would look. Everything sort of remains same. It works exactly the same, just that it'll be inside your tenant. What I've done is, and of course, because we are doing production, we can't just use those 10 documents. Let's try to challenge ourselves, right? And to do that, I actually took this challenge. I said, okay, I'm not going to work on those 10 documents. I'm actually going to work on more than pretty much like 30, 35 documents. And then I created categories. I said, okay, let's call categories like blog posts, earning calls. So if you open this, I have a bunch of earning calls. I have a bunch of podcasts. So I have a Dialog Dispatch podcast, converted all of that into the MP3. I have product launches videos. So I have Gemini product launches videos there, and the reports. Again, for year-wise, so 2023, quarterly reports. I have annual reports for some years. So you can see that I really went out of the way to make this really complex, right? But then this mimics like the production flow. this mimics something that we would essentially try to do in the end, which is you'll have your data sets like this, and this is again inside the cloud storage, if you notice. So this is not sitting outside in the world or not in the Google Drive. This is sort of sitting inside the cloud storage, secure, only accessible to specific people. And just to show you these files, this is the same PDF that I was showing you, but this time this is sort of on the cloud. I have videos now, which are sort of product launches and things like that. I have audio, which is earning calls, and so forth. Let's try to build this thing. And we'll go step by step. My goal here is not to sort of confuse you, but sort of go step by step. I'm going to give you all these steps in a very simple format. It sort of assumes a lot of things, but it's okay. We'll sort of go through it. Again, the notebook links if you want to. But before we build that, here's how things should look like. By the end of that notebook, if I put a query, and let's say there's a black box, if I solve that, a function called getAnswer, I should be able to get that answer. This is very different from what we were doing in the prototype, right? Because in that, we were passing the file and then asking the question. This, I'm not even passing anything. I'm just asking a question and letting it figure this out for me so that I can just get the answer. That's what we are aiming for. And it's quite easy. Like if once you get the hold of it, what we are trying to do, it's very easy, simple design pattern. Okay, so not boring you with all the authentication, importing and everything. I'm using two models. I'm going to use both the models just to see how things change, just to spice things up. Let's start with the first process. There's a lot of pre-processing that we need to do in order to sort of make this achievable. The first step I do is I essentially go through each document that I have. If you go through I'm not sort of also going through the helper functions that makes us do that. But if you actually go through, you'll see that I'm not downloading anything. I'm actually doing all of this in memory. So I take the storage, I take the blob, I do all of this processing, and then save it nothing outside of it. So the simple process here is I go to each document, which is a PDF. I extract all the documents and the pages. And then I come up with something like this, which is like a metadata. So I have a text type, which is like whether it's a quarterly report, which year is it. I have a GCS path, so this is not accessible outside. I have page number and the text which is there. So that's what the first step I'm doing. And this is how that metadata looks like. And you'll see how and why this becomes very important. If you see the amount of files and the pages I'm processing, these are the files that I have, and it shows how many pages it has. Again, we are trying to push the boundaries of what we can do with these models. We are trying to see whether we can do that or not in the first place. The total files I have are 32. Sorry, I said 40 total files. I think it's more than 50. The total pages are 1,600, and that's what we are trying to challenge. And if you just see one page output, you'll see that this is what one of the pages random index sort of looks like. Let's do the same thing with audio. I take audio, I send the audio to 1.5, and say, hey, can you summarize each and everything from the audio? I'm not trying to transcribe the audio at this point. I'm just trying to say, hey, just tell me what this audio is all about. Just give me the high-level summary. And later you'll see why we are trying to do that. Once I do that, and you can again see it's the same process, I have a prompt that I've written. So I'm now trying to sort of go a bit more in the prompting. I'm trying to be very specific. I'm giving it specific things, saying summarize, contextualize, analyze, synthesize. I'm giving it specific things. And again, it goes through each of it. And you can see it took 14 minutes on 18 files, roughly less than a minute, to process all of those MP3 files, gave me the metadata, and this is the output of it. So you see it says thematic analysis of alphabet earning, and then it goes into segments. It goes into different segments of where the audio, who's the speaker, because I've written this in my prompt. I've said that can you break this break all the things into segments, and then in the end you'll see there's a Q&A session, conclusion, prominent themes, and overall purpose. Good. I did this with all the audios. The next step is obvious. I'll do the same thing with video, which is to say I'll write a prompt, and I sort of, again, you can come up with your own prompt, but I'm saying that do a concise summary, thematic context, connections, and so on and so forth. Again, it goes through all the video files. It took 13 minutes, and all of this I'm doing in Gemini 1.5 Pro. I'm not using Flash here because I want to be very accurate. I want to be, and maybe accurate is not the right word, but I want to be very comprehensive and sort of go through each and every layer of it. Which is again less than a minute for each video, because I have 18 files, and it took 13 minutes to extract all those things. Again, let me show you how the output looks like for one of those files. Segment 1, segment 2, segment 3, synthesis. Again, it's following those instructions in the prompt that I've given. Okay, so far so good. So now I have these three data frames. One which has text, which is extracted from the PDF. Second is the audio summary. The third is the video summary. What's the next step? So the next step is very simple. You can imagine that these are such a huge text in one go. And because I'm trying to find similar things, and we saw that the analysts are asking very very specific questions. They're not trying to ask a whole story to you, right? So I want to chunk all of these things into very small segments. And for an example, I took 500, but this is what it means. You take the text, you split all of these text individual, and then split them further into chunks. You can do a lot of innovations here, a lot of experiments. I'm not trying to tell you this is the right way. I'm just saying that I did, in this example, 500 character split, which is to say, just to show you an example, imagine if this was the main text in the page. It got split into 3 smaller components, which is the ones that you see down. This will help me because, again, remember, the analysts are going to ask very specific questions. I want it to find the information which is specific to it, rather than going through the whole document, because the specific information may be in those specific chunks. Okay, so we're done with the chunking. The next thing I do is I take each of these chunks and I send it to the text embeddings. Again, like I said, all we need to know is these embeddings are important because with these embeddings, you can then find similar things. So you can say, hey, this is what analysts have asked, and these are all my chunks. What are the chunks which are similar to it? Now, I'm sure you would understand that because you can do that, you can actually find which videos and audios are also going to have the answer which analyst is asking. Because we have converted everything into text, we had the summaries of audios and videos. That's one part of the problem. And you can imagine this is very similar to the RAG pattern. Again, for those of you who know, you know this is how RAG works. We'll do, again, one bit of sort of complexity there. And like as I said, like I used to call it spiciness because I'm trying to sort of make myself take that challenge. So we'll do one change in the RAG pattern, which is I get the text embedding, all good, but let's try to see if we can, rather than passing the text, can I pass the actual file to Gemini 1.5? And we'll see that in a moment. So now if you see the final data, the 3 data that we have, or the one that we are calling it as metadata, we have embeddings, we have GCS path, we have text, we have page number. And again, you would notice that I'm maintaining all of this because I need the citation. I need to be very sure. The analyst needs to be very sure because they can always go back and say, oh, this is saying from this document, this page number, let me sort of go there and check this. That's why I'm maintaining all of this. And all 3 data, you can see there are a bunch of numbers as an embedding. The last thing that I do, and then we'll do the big reveal, is the fact that I'm just building a simple index. I don't want to search across 3 data frames. It's going to look very stupid. I also don't want to keep all the text and everything. I just want embeddings and the index, some kind of index, so that I can go back and figure this out. And this is that vector DB kind of things, right? You've all heard vector DBs making all the things. You can store it in open source vector DBs like ChromaDB. You can use cloud to do vector search. Your choice, whatever you want. I'm using Pandas data frame, which sounds stupid, but at least it'll help us get to the point that we are trying to do. So that's my index. This is the index that we're going to use to find which files are going to have the answer which analyst is asking. And for you to know which actual file is, because if you see the actual index, there's no GCS path, so I can't go to the actual file. But we'll write a simple logic because they're all built from the same file. So each data frame that you saw also has the index. So you can do a simple one-on-one mapping and get to the original file. Okay, so far so good. So I have everything. I have taken a backup, of course. This whole step from the start till the end takes a lot of time because you can imagine just after combining and chunking all of those texts, it took roughly an hour to get all of these embeddings and everything. Again, that's a scaling question. You can sort of figure this on your own on the other side of the ecosystem, or you can sort of write Cloud Run and Cloud Function and scale things up and make this really fast. Your choice. Let's do something interesting. So I save this, I'm loading this up, all these files, and the next thing is I'm writing a simple. Now this is where the retrieval and the ranker logic comes into picture. What this simply means is that if the analyst is asking a question, I should be able to go to my index, find where the information might be available, take those files as is with whatever modalities they have, and then send those files to Gemini 1.5 so that it can give me a much better answer. Remember, this is a slight change from the RAG pattern. In RAG, you actually send the text, right? You actually send the summaries and everything. I'm saying I just need enough information. Now you would realize why I was doing the summary and not the transcribe. Because all I need is one confirmation that the answer is available in this file. As long as I know that, I'm anyway going to send that whole file to Gemini. That's the 1 million context benefit. So if you see through these functions, one thing also that you'll notice, see this. I am not even downloading anything. I'm actually reading everything from buffer. I read, I save, I extract those pages where the information is, I create a separate PDF, and that's what I send. So I'm not sending the whole PDF, I'm sending the PDF pages where the answer is. And then I create the instruction. So this is my instruction that I'm sending to Gemini saying, hey, all of these files that you have, can you please answer the question? And again, just to show you that when I actually send the files, I'm actually sending the GCS path because I don't have this anywhere local. And again, we said, right, this is important for us. We don't want anything in the middle layer. We want everything to be part of the GCS. And then in the last, I just do calling of the Gemini model. Okay, so how will this work? So once you write this thing, let me sort of zoom this up. Let's say I have a question, which is, what is the role of AI in accelerating the progress of UN sustainable development? And I have two questions. Again, like I said, you now know this enough that I'm trying to sort of always push the boundaries. So you have two questions, and I call the function that I just walked you through. Again, you have the access to the code. Go see, it's a very simple code, nothing complex. See what I'm passing. I'm passing the query that the user asked. I'm passing the index that we created, those 100,000 things. This is where you can also call vector DBs if you wish to. And I'm passing the model, and I'm saying, just give me the top 5 files where the answer is. So before I go into the answer, let me show you what essentially those citation looks like. So the question that you asked, by the index and the simple cosine similarity with the summary, it said, hey, the answer might be available in these bunch of audio files and the video files. And that's what we're doing here. We are saying these 5 files where the answer is available, I'm going to send to the model, which is Gemini 1.5. So if you see the prompt that we are sending to Gemini, just have an observation. So I write the task, I mention the questions, you can see those 2 questions, see the contextual files. Again, I'm not loading anything up. I'm not sending the summaries of the text or the way we do in RAG, right? We send all the context of whatever information is. And this is different because now I'm sending the file itself. I'm saying, hey, I don't know where the answer is. I know that it's available. I now know this. I'm just sending you the whole file, the whole audio and the video. And see how many files we are sending. I'm sending 4 audio and 1 video. That itself is like 5-6 hours of content. And asking the same question, which is the question that I had. It goes and answers that very well. So now if you see the answer, it took 54 seconds to do all the process to find those 5 files, went to Gemini, gave those 5 files, and then gave me the answer that I'm looking forward to. That's what we said. That's what we want to achieve. And it's very simple. It's not even complex. Like maybe I may sound like it something complex I've done, but it's very simple. If you go through the code, you'll get the idea. So again, because the kind of prompt that I have written, you will see that it does question, it does answer, and then towards the end, it gives me each and every attribution of the citation where this is. And that's pretty much it. If you see, I've given many more examples. So this is another one where I'm saying, how does Gemini long context work? And if you actually see it, again, gives me the answer. If you check the citation, there are video. All the video files have this answer. The next is I'm asking another question. I don't know where the answer is, but it figured out that it's available in text. Again, it gives you the answer. So that's the bit of how would you sort of at high level do all of this. And I hope this is interesting to you. And that is all that I want to show. Let's get back to the slides.